Hi, everyone. I'm Allie, and with me is Pradeep. We're both software engineers with Amazon ECS, and we're here today to talk to you about contributing functional and integration tests to Spinnaker, specifically how we went about contributing these kinds of tests to the Amazon ECS provider, and some lessons we learned along the way. So real quick, here's a brief overview of what we're going to go through today. First, why we took the time to write tests for the ECS provider, and why you should consider writing tests of your own for stuff that you use. We'll also take a high-level look at what kinds of tests live in the project and the trade-offs between them. Then we're going to dive into the specific kinds of tests we worked on and what they look like. That includes integration tests for the Clouddriver Java microservice, functional UI tests for the Deck web app, and finally, end-to-end tests for the ECS provider. Then we'll recap what we learned and show you where you can learn more. One last thing, just so it's clear, we're going to be focusing on the upper two levels of the test pyramid for this talk. We're taking for granted that everyone is writing and understands the importance of unit tests. They're just not our focus today. So why did we write tests in Spinnaker? So primarily, we wanted to make sure that future changes didn't break existing features. So in the past year, we had seen some issues with progressions in the ECS provider. Things like logic getting inverted somewhere during the course of a larger change, and then not realizing it until someone reported it on GitHub. We've also seen issues with ECS components in Deck not loading due to changes in the upstream components that didn't play nice with the ECS UI. These kinds of things make for a bad customer experience and are also no fun for us as contributors because we'd much rather spend our time building new features than doing a bunch of ad hoc debugging or testing, especially prior to a release. So it was really important for us to invest in automated mechanisms for protecting against these kinds of bugs. There are also just some general benefits to writing functional tests that we wanted to take advantage of. Tests are a good way to document expected behavior. For integration and functional tests specifically, this is a good way to document expected behavior from the perspective of a single application versus a single class or view. And tests can be run automatically during pull requests, which gets you more validation closer to development time when it's a lot easier to incorporate changes. Okay, so we bought into why we should write tests, but what specifically warrants a test? Specifically, heavier, more integrated tests like the ones we built. So what we did was looked at where this kind of testing would have helped us in the past. I mentioned earlier the regressions we'd seen in Clouddriver and Deck, so we knew that these were specific scenarios we wanted to protect against. After that, we brought our thoughts to the community. So we published some high-level test cases in a GitHub issue, which got some community feedback. We also published an RFC, which elaborated on our technical approach. So this RFC actually started as being totally focused on adding end-to-end tests, but ended up with us deciding to also pursue integration tests. And we'll talk more about why that is later. So what kind of tests exist in the Spinnaker project? So we have unit tests, which live in each repository alongside the source code. These require only additional test code along with your contribution and run as a required check on pull requests. Integration tests in the Java microservices require more setup to run and build, but also live alongside the source code. Functional UI tests operate on a similar plane as integration tests. They exercise Deck as a unit. They require more in terms of mock data, plus a bit of additional tooling to run locally, but most of that lives right in Deck alongside the source code. Finally, we have end-to-end tests. So these are a considerable step up in terms of required effort and resources to create. Here we're running against an entire Spinnaker installation. So you basically need all the compute and overhead you'd need to run Spinnaker normally. Okay, so let's dive into integration tests. So why do we need integration tests? So when I started talking to Michael Plump from the TOC about how end-to-end tests work in the nightly builds, I learned that a lot of bugs which ended up being caught by these tests actually could have been caught on application startup. So there seemed to be missing this intermediary level of tests that could have validated the service was working before exercising the whole system in concert. So we thought it made sense to try and get some assurances lower in the test stack before going for broke with end-to-end tests. In that vein, we also needed a less resource-intense way to validate that different provider deployments were working. So there's a lot of knobs to tune for every different cloud provider you're deploying to, but it's really expensive, both in terms of compute and clock time, to do exhaustive testing with real deployments. The community is also rallying around GitHub Actions as the go-to CI solution for Spinnaker. So building service level tests that could run in response to a pull request and sort of tighten up that feedback loop was really compelling. So how do the integration tests work today? So right now there are two integ test suites in Clouddriver for the Kubernetes and Amazon ECS providers. So something that came out of our early conversations with the community was learning that we weren't the only ones thinking about these tests. Herman from Armory had actually started working on these kinds of tests for the Kubernetes provider, and he really ended up being the guinea pig for building and contributing integration tests back to Clouddriver. So huge shout out to him for his great work and collaboration in figuring out what these tests should actually look like. Both test suites are structured as separate source sets within their respective subprojects. This keeps them easy to find and also better coupled to the source code they actually exercise. The tests themselves work by submitting operations to Clouddriver and then polling to ensure the task succeeded, just like Orca or Deck would. The calls to the actual provider are mocked, so neither test suite is making calls off the box. They're currently run as a required check on merges to master and an optional check on pull requests. So the reason for this is that a full run of these tests might take upwards of 15 minutes. And there were concerns in the community about gating contributions for that long, especially if the submitted change didn't interact with either provider under test. So running it and making it optional leaves it up to the code reviewer whether or not to wait for the full test suite to complete. However, once it gets merged, everything needs to pass. So if it fails at that point, you're going to hear about it. You can also just run these locally as a Gradle task. So for the ECS test, you need only Docker in addition to the source code on your machine. So the Amazon ECS provider tests work like this. They start Clouddriver normally on a random port, except we're mocking some of the AWS components because we're not running with a real AWS account here. Then each test submits a REST call in the form of a GET request or an atomic operation. So in the case of deployment operations, we submit it, extract the task ID from the response, and then use that to poll Clouddriver and check for the operation success. After the operation succeeds, we assert that the contents of the calls made to Amazon ECS match what we'd expect given the operation. So for example, if you were testing a run of an ECS service on Fargate, does it have the right launch type and all the required fields needed to do that? Or if you're using a load balancer, did it actually try to call elastic load balancing to describe the right target group? Stuff like that is what we assert on. So what have we learned since building these? So first, they're not perfect. At the end of the day, we're still mocking some required components, like the entire AWS control plane, but they get us more confidence than unit tests alone. They need to be pretty resilient and fast. These are acting as an additional gate between contributors and getting their code merged. So flaky tests or long wait times are going to get annoying really fast, especially if the contribution doesn't interact with what's under test. We also need to keep the logic of the test simple with minimal abstraction and good logging, so that debugging test failures is straightforward later. Finally, one trap I fell into is don't trust auto imports. So there are a lot of different test frameworks in Clouddriver, like Spock for Groovy, and of course JUnit 4. So your IDE may try to be helpful and auto import stuff it thinks you're trying to use, but double check you're not mixing and matching. So in my case, I wanted to use JUnit 5 exclusively, but hit a couple bugs when JUnit 4 was brought in automatically and things didn't work as expected. And then something I found really helpful was writing a simple GitHub action for my developer fork, which would run the test on each commit. So even if you don't plan on contributing a new GitHub action upstream, running all your tests on each push to your feature branch gives you a really high degree of confidence so that things will work the same after getting merged. Okay, so here's how you would run the integ test on your local machine. You can see in IntelliJ here, there's an integration test task in the Gradle pane that I can select and run. Just make sure you have Docker installed and running. Otherwise, you'll see this ugly error about application context failing to load. This is because the tests use a test container to mock Clouddriver's cache. But otherwise, that's it. You can see here that Clouddriver did start and all the tests passed against it. So now I'm going to throw it over to Pradeep for functional UI tests.
Cool. Thanks, Allie. So let's take a look at functional tests. So I wanted to start off by giving a huge shout out to Chris and Casey for all their help in adding our functional test to Deck. So to start off, why do we have functional tests in Deck, and more specifically in Spinnaker? Over the past couple of months, we've been adding functional tests in Deck for the Amazon ECS provider. And as we've developed new features and fixed existing bugs, we've actually found that there's a lot of shared logic between the different providers. And in the past, this has occasionally led to breaking changes, making its way into the code base. So one reason for us using functional tests rather than, say, an integration test or an end-to-end test is that a functional test allows us to test the UI directly without testing or relying on any of the other Spinnaker microservices. A few things that we had to keep in mind when we were writing these tests were we wanted to validate that the views were able to load. So for instance, the pipeline view or the clusters or server group views, we wanted to make sure that you could see all of the server groups or all of the pipelines that were available to you in Spinnaker. We also wanted to test some common user workflows, like the steps for creating a new server group or configuring a new or existing pipeline. And lastly, we wanted to make sure that we catch breaking changes before they made their way into the code base. The goal of our functional tests were to validate that the different UI components of the Amazon ECS provider continued to load as members of the community made code changes. We also wanted to know how we can reduce the manual effort that a developer would have to spend before every release. As Allie mentioned previously, before every release, we actually had to manually run through different user scenarios and different tests to make sure that existing views or new views that were part of the release and workflows continued to work as expected. It would have been great if we could have every possible combination of workflows tested using a functional test. We also had to keep in mind that the test cases needed to be light. We had to reduce the amount of overhead that we were creating for the development process, as every commit would run these tests. We started off by adding tests to make sure that key components like pipelines, clusters, and server groups were able to render correctly. And then we identified common workflows like configuring a pipeline or adding a new stage to a pipeline or creating a new cluster or server group. And then we would add tests to simulate this user behavior. In the future, it would be great if we can add some more test cases that go around the less common use cases. The image on the right actually shows you an example of what the Cypress interactive testing menu looks like currently in Deck. So you're probably wondering, how do they work? The functional tests are written and they run using the Cypress testing framework. There are a couple ways of running the functional test. You can either run them interactively or you can run them headlessly. So interactively being that you can interact with the test once it's completed. You can actually step back or step forward to a specific point in your test, and you get to see what's happening in the UI. You can actually watch the test run, and you can actually make changes to the test in real time. Running the test headlessly lets you run the test in the background, and it provides you with a report once it's been completed. To run it interactively, all you need to do is run yarn start or yarn run Cypress open from within the functional directory. And it opens up the interactive testing menu, at which point you can click on a specific test that you want to run, or you can actually run all of them and just watch them execute. To run them headlessly, all you need to do is run yarn functional from the top level Deck directory, and it starts the execution in your command line. On every commit, the functional tests are also run as part of a check that needs to pass in a GitHub action. So how is the functional testing logic structured in Deck? So the functional testing logic is actually split up into a couple different modules. The fixtures directory actually stores all of the mocked responses. So if you look to the right, you'll see a couple examples where we route traffic from an endpoint to return mock data from a file in the fixtures directory. The idea is that you don't need to make calls downstream or to other Spinnaker microservices, as all you really care about testing is the functionality of your UI. The integration directory will store the actual testing implementation, and the screenshots or videos directory. So these directories are unique to Cypress. They actually contain the screenshots of the tests if there's a failure, and the videos directory contains a video of the test being executed, as well as what the UI looked like throughout the execution of your test. So when we were building these functional tests, there were a couple lessons that we learned from adding them to the Amazon ECS provider. So the first thing being, make your tests lightweight. The tests shouldn't be exhaustive. You want to make sure that you're testing the user's experience and a user's workflow in the UI. You're not trying to test every possible combination of inputs and components. Secondly, you want to identify what API calls need to be mocked early on. If you don't handle every API call that's made, you can find the UI behaving unexpectedly, where different UI components like pop-ups or tabs fail to load or render, and it won't tell you that anything went wrong. It'll just hang. You want to use test IDs whenever possible. The UI can change regularly, and relying on input selectors adds extra work for every developer who has to maintain. Functional tests in Deck were previously written in Selenium, and now they're written in Cypress. So Cypress not only makes it easier to debug and to interact with your tests, but it also makes it easier to write these tests. So with Cypress, you're testing a user's behavior rather than testing specific components in the UI. And lastly, the community is your greatest resource. If you're running into an issue when you're writing these tests, or in general, when you're developing against Spinnaker, you're probably someone out there who's actually had a similar experience to you. So what we're going to see here is a demo of the functional test running in Deck using the interactive testing menu. So the first thing you need to do is cd into the functional testing directory. And once you're in there, all you need to do is run yarn start. And what this allows you to do is this will actually force Cypress to open up the interactive testing menu. It takes a couple of seconds to load. So as you can see, this is Cypress's interactive testing menu. So the test that we wrote for this talk was the server root demo. And so when you click on that specific test, you can see it's opening in Chrome. And the intent behind this test was we actually want to create a brand new server group using an artifact, and we want to make sure that it has some container inputs defined. We have some load balancers and target groups mapped, some sort of a workflow that users commonly use. So as you can see, as it's running through the different stages of the execution, you can actually see what the UI look like on the right. So here, we're just adding some example inputs. And now we're going to create a brand new artifact, and we're going to associate containers, images to that artifact. So as you can see here, we're adding some example data, and then we're going to map a container within the artifact to a specific image, and then we're going to map a container and to a target group. And we're going to use Fargate for this example. So as you can see, the test actually succeeded because if you look on the right, it is green now. And if you look at the roots, these are all the roots that need to be mocked or stubbed. And then down below, you'll actually see these are the different stages of the execution. So when we're running through and we're trying to look at configuring a new pipeline, you can actually see at which point it's doing that, as well as what the UI looked like at that point. And then when we click on that component, you can also follow it there as well. And then down below, let's say we don't really mind looking at how the configuration looks like, but we want to go in and see what the cluster looks like. So we can actually step at that point and see what it looks like when we're adding example data. And then if you want to stop the test, there's a stop button right at the top of the interactive testing menu. And what this does is this will stop running that specific test. And then when you close the interactive testing menu, it will stop running Cypress. All right, cool. I'll pass it back to Allie to talk about the end-to-end tests.
Thanks. All right, so now we've made our way up the testing pyramid, and I want to talk a little bit about how end-to-end tests happen in Spinnaker. So I'm going to hand wave over a bunch of this for the sake of time, and also because I'm still learning the details myself. But essentially, the end-to-end tests are currently orchestrated via a custom package running on a Jenkins server. So about once a day, the head of each release branch for each service is built and put together into what's called a bill of materials, which represents the hypothetical release. This is basically the list of each microservice in that release and what its individual version number is within the larger Spinnaker release. So the build tool package deploys those services as a running Spinnaker installation, configures the required accounts with Halyard via bash scripting, and then runs a series of high-level operations against it for various cloud providers. For example, it will create an application that uses the AWS provider, and it will provision a load balancer into that application, and then deploy an AWS server group into it. And then if that succeeds, tear it all down. And there are similar workflows run for other cloud providers too, including Kubernetes, Google Cloud Engine, etc. So we started looking at contributing here because there aren't currently any end-to-end tests for the Amazon ECS provider running. And we want assurance that prior to each release, the contracts between the different services are still intact and allow for an ECS deployment to succeed end to end. So this effort is still underway, but I can talk about what we've done and taken away so far. So we started by writing a design for the tests and publishing it as an RFC to make sure we understood the requirements and we're on the right track in terms of design. I would encourage anyone thinking about making substantive changes to a community process or even a single service to go through the RFC process and make sure you're aligned with where the community technical leadership wants to go. Like I said before, it was through this process we actually identified the need for integration tests. So that was a great takeaway. So our basic plan for ECS is to execute a single typical Amazon ECS deployment end to end, get it working reliably in the nightly builds, and then evaluate the need for additional end-to-end tests after that. So I'm currently working on getting the test to run locally on a test Spinnaker installation. And then I'm going to work with the build cops to figure out the best way to port it over to the community process. Takeaways I have so far are, if you want to pursue these kinds of tests, you need to solve the additional problem of configuring Spinnaker and the test environment, not just how you structure the tests. This means making trade-offs between ops and cost, both in terms of compute time and engineering resources. And finally, and maybe the biggest takeaway for me, is that the existing end-to-end test setup is not fun to work with. It's written in Python, where Java would better align with what the community typically uses. Also, the logic for how to configure the Spinnaker under test is complex and hard to parse. Also, testing new changes in this setup before merging them in is pretty difficult, which is ironic for a test setup, I suppose. So in the fullness of time, technical leadership would like to replace this existing setup with something based in Java and generally more accessible to the community. So this is deserving probably its own RFC and discussion, in its own right. So if this is something that you have opinions about, I think the community would be really receptive. So that's it for us. Some testing takeaways we'd like to leave you with are, it's easier to keep bugs out than find them later. And then you should understand the limitations of different types of tests and the levels of tests. Finally, tests save time, but they also take time. So strategically invest in what's important for you and your customers. And then some Spinnaker specific takeaways are, make sure to engage the community early to validate your approach and share learnings with others. And then you should structure the test to grow over time because it's a large dynamic open source project. Integration and functional UI tests in Spinnaker are relatively new paradigms, so I feel like there's a lot of opportunities to contribute here if you're interested in that. And then something we haven't spent a lot of time thinking about yet, but that I would pose to the community is, what would functional or integration tests look like for other Spinnaker microservices, not just Clouddriver and Deck. So that's a question we could think about later. So if you want to find us, here is where you can find us on GitHub. Or if you're interested in tests, here are some Slack rooms and SIGs that would be open to discussing them, or where discussions about tests typically happen. And then here are links to the test resources we talked about today. So that's all we have. Thank you so much.